Hello students, welcome to this lecture number 3 on chemical bonding and molecular structure. We know Lewis dot structure is basically a picture of bonding in molecules and ions, and it is in terms of the shared pair of electrons and the octet. The base of the Lewis structure is octet, the formation of the octet around the atoms, and basically that is the valence shell electronic configuration, that it should have the 8 electrons. Although this has not happened in the many molecules that we have also discussed in the limitation of the octets. Lewis dot structure is not completely able to explain the bonding and the behavior of the molecules, but it helps us in understanding the formation of the bonds, also the characteristics of the molecules. And so the Lewis dot structure, to write the Lewis dot structure in the specific way, in the correct way, that is very much essential for us to learn. And in this lecture we are going to discuss the how we can able to write the Lewis dot structure more correctly and more promptly. In this lecture we will going to discuss. So today's we will learn today the Lewis dot structure, how we can write much more easily or comfortably. Lewis dot structure. There are basically several steps, and if we learn these steps, you can able to write this Lewis dot structure very easily. That is, this is K. Mukherjee in the Science with Mukherjee Sir YouTube channel. First, let us understand the steps. Step 1, that for Lewis dot structure, when we are going to write the Lewis dot structure, we need electrons, and these electrons have been placed in the molecules in terms of bond pairs or in terms of lone pairs, right? So first step, to calculate the number of electrons, to calculate the, what we will do in the first half, we will write these rules, and the second, that will example we will take, and accordingly we proceed. To calculate the number of electrons, first to calculate the number of electrons required for writing the Lewis dot structure, for writing the Lewis dot structure. And how we can do that? It's very simple, that we have to only know the valence electrons of that combined atom. As for example, we are taking example of O3. This O3, that you can understand, it is having 3 oxygen atom, and we know the oxygen atom has the electronic configuration as 1s2, 2s2, 2p4, because it has the atomic number is 8. So here you can see the valence electron of this oxygen atom is 6. right? So total number of valence electron, first total number of valence electron. Valence electron, that we say VE, is total 6 into 3, that is 8. The first thing, by summing up the available valence electron which is going to be combined, the atoms which is going to be combined, as for example is 3 ozone. In this case 3 oxygen atom will attach with each other and it will going to produce these molecules. And to write this Lewis dot structure, first we have to know how many electrons are there in the valence shell. Not total electrons, we are talking about the valence shell. Okay, that is the first rule. Second rule, what is? Now we have to make a mental picture of each structure. Mental picture of the structure of this molecule. Mental picture of structure of this molecule. Structure of the molecule. Mental picture means how these oxygen atoms has been arranged. So let us understand this oxygen atom. This is one oxygen atom, this is another oxygen atom, and this is another oxygen atom. Now we know the total valence electron is 18. This valence electron we have to distribute in terms of lone pair, in terms of bond pair. So first we will do bond pair electron, BP. First we will write 2 bonds here and 2 bonds. This is a 2 bonds here, right? And we know for constructing a bond means you require 2 electrons. So total bond pair we have used 4 electrons. Balance is 14 electrons, and these 14 electrons, the third thing that after doing the mental picture we distribute electrons into bond pair and lone pair. So we are taking the bond pair, that is 2 electrons. Now we will satisfy, now we will fulfill the octets of all the oxygen atoms by utilizing the valence electron. Valence electron how many? 40. So for this let us do the octet of this oxygen, this and this. So total we have used 6 electrons. Right, 6 electrons will be used, and we find the octet of this oxygen atom has been fulfilled. Now we go to this oxygen, 2 electrons, 2 electrons, 2 electrons. But each octets also be completed. So here you can see 1, 2, 3, 3. Total 12 electrons you have utilized. 12 electrons we have utilized. Now we are going to utilize 12 electron is there. 12 plus 40 means 16 electrons we have utilized. This is total 12 electrons and it is 12 and 16 is utilized. We are left with only 2 electrons. So we put these 2 electrons in this central oxygen atom. Now you see this oxygen atom fulfilled its octet. This oxygen atom also fulfilled its octet. But this oxygen atom is not fulfilling because it is only having the 6 electrons. So what we will do at that time? At that time our rule is that number 4th rule, resort to the double bond. Resort to double bond. Resort to double bond means thus we have to use this one of the pair, then we use this pair here, and now you see the octet of this oxygen atom also fulfilled it. 2, 2, 6 or 8. So now this is, we can say, the Lewis structure, Lewis dot structure of these O3 molecules. Okay, we understand what is Lewis dot structure, and at the end you can see there is a bond pair. We have utilized 18 electrons into 6 electrons in the bond pair, and remaining are in the lone pair, that is 12. You can see 12 electrons, 1, 2, 3, 4, 5, 6. 6 pair of electrons is lone pair electrons. These are lone pair electrons. All these electrons are lone pairs. This is lone pair, this is lone pairs. And this electron is bond pair. You have to understand, when we are writing the Lewis dot structure, you have to understand that's very important thing. What is bond pair and what is lone pair? And this lone pair of electron is very much essential to understand in different ways. When we go for analyzing the bond angle, or we go for the behavior of the element in other terms, these lone pair and bond pair electrons will be very much helpful. One theory has been proposed, that is valence shell electron pair repulsive theory, that we will discuss later on. That is also based on this bond pair and lone pair. Okay, I think that is understood. That first we have to calculate the total number of electrons. We need to write the Lewis dot structure. Second thing, we have to make a mental picture. Third thing, that we have to distribute all those electrons available to us as a bond pair, as a lone pair, and then we have to judge whether the octet has been full satisfied by all the atoms in the molecules or not. If it is not, then we have to resort to the double bond. Okay, that is how we can able to write the Lewis dot structure. Now we are going for the ions. Suppose it is one ion is there, then how can we go for this Lewis dot structure? Okay. Now we are going to write the Lewis dot structure for a ion, that is carbonate ion. So first we have to do what is the valence electron, total number of valence electron. Here the carbon, we know it is having the valence electron is 4, oxygen we know that is 18, and for the ions, when there is the ions and it is anions, then we have to do for each and every negative charge, you have to add 1 electron. Here you can see this is 2 minus, means you have to add 2 electrons here, and it will be total number of electron is 24. After this, what we will do? We will write the mental picture of this molecule. Now what we will do? We put a bond, 3 bonds here. So bond pair electron is 3, means 6 electrons we have utilized. Total remaining 18 electrons, and these 18 electrons we will utilize. First we will satisfy the octets in these periphery atoms. Here this atom is called central atom and this atom is called peripheral atom. When we are going to construct the Lewis dot structure, at that time the less negative elements will be acts as a central atom, and the peripheral atom is the oxygen atom. Here it is a less oxygen atom. There is a higher negative and it is a less negative. The less negative atom will be the central atom, and the Apart from this, here the oxygen, the other atoms will be the peripheral atom. So in this case, then what we will do? We will put this, we are satisfying the octet of this oxygen, and we can now see total we have utilized in the bond pair, we have utilized 6, and lone pair we have utilized here, that is 6 electrons. 6 electrons. Here also we have utilized 6 electrons. 6 plus 6, and we have 6 electrons remaining, that we have utilized these 6 electrons here. Okay, so you can see that oxygen has achieved this octet of electrons, this oxygen also and this oxygen also. But what about this carbon? Carbon is not satisfied this octet. It is having still 6 electrons. So for that what we have to do? We have to make a bond, double bond. This will be double bond. And now you see, carbon is 4 octet of electrons. So here we can write another bond pair 8, and total lone pair of electrons, that will be 16. 16 you will use 1, 2, 3, 4, 5, 6, 7, 8. Right? So total 16 electrons has been used as a lone pair and 8 electrons used as a bond pair, and in this process we find the carbonate ions Lewis structure is this. Okay, very simple, that we can able to understand how we can able to draw the Lewis dot structure of anything. Now where suppose carbon monoxide. In case of carbon monoxide, what we have to do? First, valence electron. How many valence electrons is there? Carbon having the 4 valence electron and oxygen 6. Total 10. Then we have to make a picture skeleton of this carbon monoxide. Make a bond here. So bond pair, we have utilized 2 electrons. Remaining is 8 electrons, and these 8 electrons we will utilize here. The oxygen octet it, fulfilled it. Now we put this lone pair here. Now we see oxygen has satisfied its octet. Yes, I am fulfilled it. But what about this carbon? Carbon still it is having 4 electrons only 4 electrons. So it wants more. How do we do that? And this it can easily do by making another 2 bonds. So these 2 bonds, this will be, now you can see the octet of both these atoms has been fulfilled. Here you can see 8 electrons, here you can see 8 electrons, but there is a triple bond is there. So here bond pair electrons, how many? 6. 6 bond pair electron, lone pair electron is 4. Right? So now understand this Lewis dot structure. You can do from the other molecules also. Suppose we are taking another molecules HNO3. For this HNO3, first we have to calculate the valence electron. Valence electron, hydrogen is 1, nitrogen is 5, and oxygen is total 18 electrons. So we will get how many? 24 electrons. Right? Total 24 electrons we get. Now we make a picture of this. Naturally, nitrogen will be the center atom. Then HNO3, HNO3. First, we have calculated the bond electrons, total valence electron is 24. Then bond pair we have utilized already. Bond pair electrons how much? Here 2, 1 bond pair, 1, 2, 3, 4. Total 8 electrons already been used for the bond pairs. Then we go for the satisfying the lone pair, satisfying the oxygen octet of the oxygens, other oxygens atom. These are satisfied. Here you can see 6, 8, total use 6 electron lone pair we have used, that 6. This is 6. Again we have used 6, 12, total 4 electrons remaining here that we can utilize here. See, now hydrogen has, this will not be octet, this will be duplet. 2 electrons already in their sharing. After sharing, 2 electrons is now get. Now oxygen, you can see this oxygen is fulfilled at its octet. This, and here also. But what about this nitrogen? Nitrogen has been 6. So you have to give nitrogen 2 electrons. From where you have to give? You have to make a bond here. Right? Now the fulfilled it. And in this process, how many bond pair we have utilized? Total 10 electrons has been used in the bond pair. 10 electrons, 1, 2, 3, 4, 5, and remaining 1, 2, 3, 4, 5, 6, 7. Remaining 14 electrons. 14 electrons as a lone pair you have used. See, total electron is this. You can also cross check after writing the Lewis dot structure whether it is correct or not. You can cross check what you have utilized in the lone pair or bond pair and whether it is been tallying with the total. By this way you can able to understand. So I think that is very much clear to you that how we can able to construct the Lewis dot structure. This can be easily be done. First we have to know the valence electrons of these atoms which are going to be the Lewis structure for which we are going to construct. First we have to know the valence shell electrons. Then we have to know the how we can arrange these atoms in the molecules. Then we have to know that you have to put the bond pair first. Then we have to satisfy other peripheral atoms, the octets. Then you have to go for, if required, the multiple bonding or double bonding or triple bonding. In this way, you can able to easily construct the Lewis dot structures. And this Lewis dot structure is very much essential to know, because from this you can able to know about the properties of the molecule. It can give you a understanding. Also, it will not going to give many things. That is, it will not able to give you the shapes of the molecules. It will not able to explain why the energy has been evolved when the bonding is formed, how the atoms are arranged in the. This also not being provided by structure, but it is going to give you a overall direction, overall application of molecules. Okay. Now we are going to discuss another very important thing, that is the formal charge. For polyatomic ions, as for example, that is CO3 2-, carbonate ions. Formal charge we are going to understand. For the carbonate, for any ions, any polyatomic ions, the charge carried by this entity is as a whole. It is not like that carbon will carry this charge, oxygen will carry this amount of charge. This is not. It is basically total charge carried by the ions. But for practical purpose, for some reason, we can assign some formal charges to these ions, to these atoms of the ions or molecules. How you can do this and what is basically formal charge is defined? How formal charge is defined? The formal charge is basically the difference between the valence electron when the atom in the free state, suppose in this case carbon, suppose carbon, we want to know the formal charge of the carbon. So first we have to know the valence electron and the electron assigned in the when it is in the Lewis dot structure. Some electron will be assigned to fulfill its octet that will be different from the valence electron, and this difference is going to create the formal charge on this particular atom. So we can write the formal charge on an atom, formal charge on an atom in Lewis structure, in the Lewis dot structure, is basically the total valence electron, of that atom, right, minus total valence electron of that atom in the Lewis, in the molecules. Now on the of that atom when at a free state, or isolated state, free state or isolated state, minus the non-bonded pairs, or you can say lone pair electrons. Lone pair means total numbers of lone pair electrons, and minus half of total numbers of bond pair electrons, right? This is the formula, the total valence. You have to know the total valence electron of this carbon. Then you have to know what are the, in the Lewis structure, what is about, is there any non-bonded pair of electron or lone pair of electrons, or what about the bond pair electrons. From this you can able to get a formal charge. So let us understand for this carbonate ion. The carbonate ion, and we have to calculate the formal charges. This is one position of 2 position electron oxygen, and this is the 4th position in the carbon is there. First we have to calculate the oxygen, formal charge of the oxygen in the first position. In this case we know oxygen have the valence electron 6, Then non-bonded pair. The lone pair, it is having total 4 and half of bond pair. Bond pair, it is having only 2 electrons, that we will put 2. So what we will get? We will get total 6, 2 minus 1. That we will get this will be 6. 6 is the lone pair electrons and this will be minus 1. So in this position the charge will be, negative charge will be minus 1. Formal charge, you can say formal charge. For the second oxygen atom, you will find that 6, again similar way, 6 minus half, 2, it will be also minus 1. Then this, the third oxygen atom, we will see 6 minus 1. So here lone pair electron will be 4. So this 2, that will be 0. For the carbon, atom, that you will find that carbon is 4 and it is no lone pair and it is half into total bond pair, how much? 8, and it will be 0. So we can see the formal charge here in this carbon atom, here 0 and here 0. So for this, what we have to do? We have to first write the Lewis structure much more comfortably, much more correctly. After that, we have to, with this, using this formula, we can able to know the formal charge on the atoms, particular atoms of that molecule. Okay, I think that is you understand all the things that have been told to you. And if you like this video, you can share to your friends. Thank you very much for watching, and next we will discuss different topics on in this chapter, that is atomic bonding. Thank you very much for watching.